Hey folks, Mr. Dell here. Hey, we're going to explore a little right triangle trig and make sure we understand the relationships between our trigonometry and our right triangles and their the ratios of the sides. So this is a problem that I'm pulling from CPM. This is integrated math 2, and right there, section 6.1.3, number 6-30. So it says in a right triangle, okay, so we've got a right triangle. I want to just draw my best right triangle here. All right, so right triangle. It says the sine of theta. Now theta, so that little symbol, by the way, just for those that don't know, that is theta. That's how you say it. Greek symbol theta. And theta is used a lot when we talk about angle measurement. So I would say that this is theta. We don't know what it is, some degree measure of an angle, right? It's just an unknown degree. It's like you could call it x, but they call it theta. So in this case, the sine of theta is 8/17. Well, a little review. If you haven't learned this, right? SOHCAHTOA, SOHCAHTOA, right? SOHCAHTOA. What does SOHCAHTOA mean? Remember, the sine is always the ratio of those two, which O represents the opposite, H represents hypotenuse, and A represents adjacent. And what does that mean? So on your side lengths, if I'm talking about the sine of theta, here's my theta. And what we know is sine is the ratio of opposite over adjacent. Excuse me, opposite over hypotenuse. That's the H. So opposite is, well, if this is where the theta is, opposite is always opened up to it. So this would be the opposite. So it's the ratio of 8 because it's opposite over hypotenuse. So that means that this is 17 because the hypotenuse is always the longest side of the triangle, the one where the 90 degrees points to. Okay, so my ratio sine of theta is equal to 8/17. So that's how I was able to label those sides. Now I need to find cosine. This is cosine, right? Cosine, SOHCAHTOA, is adjacent over hypotenuse. So here's the sine of theta still here. So it's this side. It would be this side here, that one over the hypotenuse. So I've got to figure out, I need to figure that side out is what I've got to do now. So I've got to figure out what is this side here. I don't know what it is, right? Oops, gotta get my pen back up. So I got to figure out what that is. Let's call it X per se, because I don't know what it is. So I can figure that out though by using another theorem I have with right triangles, and that's Pythagorean theorem. I know that a squared plus b squared is equal to c squared, right? So if I'm going to try to find my missing side here, this x, I could say 8 squared plus the x squared is equal to 17 squared, because I know two sides of a triangle. If I know two sides, I can always find the third. So this is 64 plus x squared is equal to 289 when you square 17. So subtract 64 from both sides to get my x squared alone here. I end up with 225. And oops, 25. And then to solve for that x, remember what you do is we take the square root of both sides to get x alone. So x in this case is equal to 15. The square root of 225 is 15. So that's it. I just found that missing side is 15. So if I know now, I know cosine of theta is 8, right? Opposite of theta, opposite of hypotenuse. Cosine is adjacent over hypotenuse. So adjacent in this case is always the side that the angle is touching along with the hypotenuse. So it's 15. So we can answer right here, cosine of theta is equal to 15/17. So there's my answer. And my justification is my drawing and using Pythagorean theorem. Okay. To finish my notes over here, though, just so you understand it, why SOHCAHTOA, TOA is the tangent, and tangent's always opposite over adjacent. So if you're trying to find the tangent of something, it's the opposite over the adjacent ratios of sides. All right. Okay. I hope that helps.